This is our first video on the domain of the composition of two functions. Recall that a domain is typically the set of numbers, of real numbers that you can put into a function and get one real number out. Right? So for these two functions, we want to consider the domain of g of f. Let's start just by computing g of f for a couple x values. Right, suppose we want to compute g of f when x is equal to 4. We're going to apply f to 4 and then apply g to that result, right? Well, f of 4 is 2 because the square root of 4 is 2. G of 2 is 2 squared, which is 4. So when we put 4 into our function, we get a real number out, and so 4 is certainly in the domain of g of f. Let's compute g of f at another value. Let's try to compute it when x is equal to -1. So we're going to apply f to -1, and then apply g to the result. F of -1 would be the square root of -1, right? So we cannot even compute f of -1 because we're not going to get a real number out. -1 is not in the domain of f. Okay? So when we think about domains of compositions, at the very least, the x value must be in the domain of the first function. Right? Consider the typical picture for composition. Right? We have some x value. We apply some function f to it, and we get a result, and then we apply g to that result. Right? So compositions are a two-stage sort of function. At the very least, the x that we start with must be in the domain of our first function.